Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Mellanox. We have Gilad Shainer. He is the VP of Marketing at the company. Gilad, how are you doing today?
I'm fine. Thank you very much for having me.
Well, thanks for coming on, Gilad. You know, we're just a few days away from the start of supercomputing, SC15 in Austin, but I thought we could take some time to catch up on Mellanox and see what's going on. I mean, you must have a lot of activities planned for this week.
Definitely. We plan to announce several new products. And today I'm going to talk with you about one of the products that we're going to announce. As well, also give a view of Mellanox on where we're heading and what's new and what's going to be exciting.
Okay. Well, sounds good. Well, Gilad, I brought your slides up. Why don't we start there, and we'll do a Q&A at the end.
Great. So let's start with slide number 2. And looking a little bit to the history, right, and to the future. Basically, in 20 years, we'll achieve 1 million X performance improvements, moving from terascale to petascale and now going toward the exascale. And during that time, during the 20 years, we're going through 3 technology changes that enable to overcome performance walls and to drive us to the next level of performance. So, you probably know as well as I do the move from SMP to clusters, which enable us to go to the terascale era. SMPs become too complex, they don't scale. So moving to clusters, essentially taking off-the-shelf servers and use high-speed interconnect in order to form a cluster, enables to build a more cost-effective and scalable infrastructure and to take us to the terascale. Later on, as you know, we move from a single core to many core. Again, performance wall of cannot get more performance from increasing the frequency of the CPU. Then they need to go to parallel, use more cores. And essentially also the interconnect was important here because instead of a single process running on a server, now you have multiple processes running on a server. So the network needs to handle multiple cores and to be able to scale. But that was another technology change that enabled us to go into the petascale. And now we're going through another technology change, which is called co-design. As we're getting to performance walls again, due to cost, due to price, due to technology capabilities, and co-design is something that is taking us to the next level of performance and will lead us into exascale. So what co-design is? Simply saying co-design is moving from a CPU-centric view, where everything needs to run on the CPU. And that approach is getting us to a performance wall, and it limits us from what we can do forward from here to a view of a co-design. And a co-design means is that you create synergies. You create synergies between the software and the hardware. And you create synergies between the active component in the data center. And basically, you take an application will run on every active component that exists. The part of the application will run on the CPU. Part of the application will run on the network. Part of it will run on a storage, and so forth. So each active element in the data centers provides a computing element to be able to run the application and working in synergies. And that synergy enable us to overcome the performance walls of today and take us to the next level of performance and essentially drive us toward the exascale. So what does it mean, synergies from an interconnect perspective? It means is that the interconnect become more and more and more intelligent. So there are more things that are being moved to the network, and the network is becoming a more and more important part in running the application. The network is starting to provide in-network computing as part of the application runtime, offloading the CPUs, reducing from the CPU's utilizations and having more CPU cycles dedicated to the application, and also be able to work on the data when the data moves within a data center. And that capabilities enable that capability of working on the data when it moves within a data center enables you to do things that you cannot do on the CPU. And that's where the next level of performance is going to come from. So what does it mean, the intelligent moving to the interconnect? It means offloading technologies. And more offloading capabilities moving to the network. We all know about RDMA, one of the key offloading technologies that started years ago. And today, RDMA is the de facto solution for storage, for machine learning, for databases, for data analytics. Without RDMA, those applications will not be able to scale. So no one is running storage today, for example, with no RDMA. You must have RDMA there if you want the storage to scale. So this is one example. GPU Direct is another example, which enables a 10x performance improvements for GPU-based systems. And there is other elements of direct communications and software-defined networks and programmability that is bringing on. And more things are moving to the interconnect as part of offloading technologies, which make the interconnect more and more intelligent. One very important element to remember is that you must maintain backward and future compatibility. Because elements that you bring now into the networking as part of technologies, you want to continue and maintain them. You want to protect your investment. You want to continue and scale with the application. So backward and future compatibility is important, and it's definitely drive the elements of standard protocols, standard solutions, and open source. I'll give you one example of a performance wall where the elements of intelligent or co-designs become critical in order to solve those issues. Let's look on the latency wall, for example. So 10 years ago, network devices were running in tens of microseconds each. And the communication framework, the application latency, the collective operations, for example, were running in hundreds of microseconds. Today, network devices are in 100 of nanoseconds. So there was a 100x performance improvement. On the other side, the communication frameworks are now in tens of microseconds. So if in the past the network devices, the latency of them was a major part, now it's become negligible. We're talking about hundreds of nanoseconds compared to tens of microseconds. So moving to the future, we still expect the network devices to continue and show reduction in latency. But you're getting close to physics limitations. So from 100 nanoseconds, you can go to 90 nanoseconds, 80 nanoseconds, 70 nanoseconds. But that become negligible, or the saving here become negligible when you compare it to the tens of microseconds. So how do we enable another 10x performance improvements in the application side, knowing that it needs to come not just from reducing the latencies of the network devices, because that's become negligible compared to the communication framework. The solution here is by creating synergies. By taking the communication framework and saying, I'm not going to run that entirely on the CPU. No, I'm going to run things part on the CPU, I'm going to run part of the network. And when you run and do manipulations of data, or you're doing operations on the data when it flies within a data center, you can hide things, you can do things in parallel, and you can achieve another 10x of performance improvement. And for that reason, or for bringing more attention to the network, or for enabling the next 10x of performance improvement, we're announcing Switch IB2 at Supercomputing 2015. And Switch IB2, it's the world's first smart switch out there. So Switch IB2 essentially provides all the elements that you expect from the best switch out there. It has the lowest latency of less than 90 nanoseconds. It's the fastest switch compared to anything that exists and will exist. It has 100 gigabit per second per port with 7 billion messages per second, meaning 195 million messages per port, and 7.2 terabits of throughput. It supports adaptive routing, congestion controls, multiple topologies, anything that you expect from a switch. But this switch is the world's first smart switch because it's implement a new technology is called Sharp that enable the switch silicon, to manage and execute MPI collective operations on the switch itself. And that enables a 10x of performance improvement. So the Sharp technology enables switch IB2 to manage and execute MPI operations in the network. And it's being implemented in the switch silicon itself. And this is the first time where the switch becomes a coprocessor in your system. And when you think about the collective operations and how they're being executed today, so today you run MPI, the collective operations from the server. You can run those operations on the CPU or some of the operations on Mellanox NICs, but it is being executed in the server. And when you run a collective operations from the server, that operation requires you to go multiple times across the network where that specific endpoint needs to communicate with any other endpoints in the system. So regardless of what you do in the server, executing an MPI collective operation requires you to go multiple times across the network. Now, when you move that operation to the switch is the entity that essentially connects to everything. So it can implement or execute a collective operation in one iteration. And that enables you to make those massive savings and increase the performance by 10x. So there is nothing you can do on the server side, and nothing you can do if you continue running everything on the CPU that will enable you to achieve a 10x performance improvements. So that's why Switch IB2 is so important for us to drive the next step of performance and driving us toward the Exascale. So if you look on the map of active devices, we have the CPU that run the application and responsible for the application. On the adapter side, which, for example, ConnectX-4 from Mellanox, which is the 100 gigabit per second adapter, provides multiple elements of offloading engines or intelligence. It does the transporting hardware, the RDMA, SIOV, collective, GPU direct, and other things that essentially enables you to reduce the CPU overhead and achieve greater efficiency on the application side. And now to ConnectX-4, we're adding Switch IB2, which is the world's first smart switch, which also take part of the application runtime, offloading the CPU, and basically doing something that you will not be able to do on the server. So saving those multiple operations, executing an MPI collective operation in one network transaction, and reducing latencies from tens of microseconds to a low single digit of a microsecond. That's the huge benefit of Switch IB2. So Switch IB2 is part of Mellanox end-to-end solutions for 100 gigabit per second. We have ConnectX-4, which beside of the message rate and the lowest latency out there and supporting for all of those speeds, also bring offloading and accelerations, supports for RDMA, and other things like that. We have now Switch IB2 that beyond of 90 nanosecond latencies, 195 million messages per second per port, now also brings the Sharp technology for executing MPI collectives on the switch silicon itself. A few months ago, we announced Spectrum, which is the 100 gigabit per second Ethernet switch that supports all the Ethernet switch from 10 to 25, 40, 50, and 100. And to connect everything, you have the LinkX transceivers and cables family, providing active and optical and copper cables. So both VCSEL and silicon photonics for any of the speeds all the way from 10 to 100 gigabit per second. So to summarize the view of intelligent interconnect and why it's important, basically it drives or enables two things. One, it's reduced the overhead from the CPU. So it takes the network functions that are being running on the CPU and move them to the network. So it's free the CPU cycles, and you can gain more efficiency from the CPU. The second part is that bringing more and more intelligence to the network enables the network to become a coprocessor. And there are things you can do on the data when it flies, which you will never to do in the same efficient way if you do it on a CPU. And the sharp technology is one example. So the network not just increase your CPU efficiency, but also increase your data center performance by adding more intelligence to the network. So we all know about the Coral project, which put two systems, one in Oak Ridge and one in Lawrence Livermore, as well as other systems that Mellanox is proud to accelerate around the world. The intelligent networking and switch IB2 and the sharp technology, this is part of Coral. So it wasn't announced before, or when Coral was announced, because that information was confidential. But now, as we announce Switch IB2, we're happy to say that Switch IB2 and the sharp technology is part of the Coral project and will enable application running on those systems to achieve a great level of performance compared to anything that exists today or will be from a competition. When we talk about the intelligent computing or intelligent networks and bringing offloading capabilities and driving performance, we can compare on what we do versus competition. So first on the Mellanox side, driving all the way from 10 back then through 20, 40, 56, which is FDR, 100 gigabit per second today, and now moving towards 200 gigabits per second, which we expect to release in 2017. Those generation enable the fastest machines out there and deliver performance advancements through offloading technologies or offloading capabilities. If you look on the competition and a no offload approach or the onload approach started back then in 2006, around 2006, when Pascal came with a competition to Mellanox on the InfiniBand side, and the products called InfiniPath, which were running at 20 gigabit per second InfiniBand. And the difference between InfiniPath and Mellanox adapters were that Pascal went the easy path of doing a no offload approach and no offload network. Why? Because it's easier to run everything on a CPU. You don't have to invest so much in building an efficient and scalable hardware for the network. So they did a no offload approach, no RDMA, no acceleration engines, everything on a CPU. Essentially, that doesn't provide efficiency, it doesn't provide the scalability, and it doesn't enable you to take advantage of the CPUs in the systems. And basically, they failed. Now, QLogic acquired the Pascal technology and kept the same no offload approach and just run it in a 40 gigabit per second InfiniBand. And they failed from the same reasons. No RDMA, no acceleration engines, it means no efficiency, it means no scalability, and they failed. Now, Intel acquired the same Pascal technology through QLogic, and now call it OmniPath instead of InfiniPath, and running in 100 gigabit per second, and even changing the protocol to be a proprietary protocol. But it's the same no offload approach. Everything needs to be run on the CPU. There is no RDMA, there is no acceleration engines, there is no MPI collectives, there is nothing. Everything is on the CPU. So that approach is great if you want to sell more and more CPUs, but it doesn't enable you to gain the efficiency from the CPU. It doesn't enable you to achieve scalability, and it doesn't enable you to compete on performance. So that's why we believe that Mellanox will continue to provide a superior performance, superior capabilities, and enable our customers to be a generation ahead over competition. So when we look on even the simple numbers and comparing Mellanox EDR today, which is robust, reliable, being used out there in multiple systems, compares to OmniPath. So Not even talking about RDMA and the offloading capabilities and the great efficiency, but even looking at the simple numbers. Look on power consumption. Mellanox needs 25% lower power per switch port. That's pure OPEX saving. On systems that exist today, measured message rate provide 44% higher message rate. Measured. 20% lower switch latency. Pure performance. And then when we look on scalability and efficiency, and the differences between an offload approach versus a non-offload approach, typically results in 2x performance difference and 2x differences in efficiencies. So that's why we're going to continue in showing a performance advantage on the applications and on the entire data center. And even more than that, Mellanox released the first 100 gigabit per second solutions in end of 2014. We have multiple systems out there working in production and robust. We'll be in 200 gigabit per second in 2017. And we expect Intel on the story on packaging and things of that sort with OmniPath to be ready late 16 in the 17 timeframe. So that means that Mellanox will continue to maintain a generation ahead advantage on the throughput and definitely a generation ahead advantage on the efficiency, scalability, and overall data center performance. So if we go a little bit in more details on some of the numbers and covering the performance element, and again, not talking about RDMA, not talking about acceleration engines, just the simple numbers. Mellanox enables today 100 gigabit per second throughput at 0 CPU utilization. 0. OmniPath can do 100 gigabit per second, but it will take a lot of the CPU cycles. The adapter is running 150 million messages per second, which is 44% higher versus the competition. And the switch does 195 million messages per port. Now, looking on latency, the switch is 20% lower latency with a deterministic latency, not a range, not something that depends on where the port is, but deterministic latency. If you're talking about total cost of ownership, we mentioned the 25% lower power consumption. Mellanox is a standard-based solution. So you have the ecosystem, you have the open source, you have the standardization, which means that it's backward and future compatible. You can take UDR to connect to FDR, to connect to EDR, and to connect to HDR in the future, and so forth. So you maintain your investments. It's not a proprietary network that work only with itself right now, and future generation might not connect to previous generations. So you have the investment protection when you use InfiniBand. And bringing the offloading architecture, I think that this is the major thing. Having RDMA, not having RDMA for storage, that's a killer. So you need to have RDMA for storage. You need to have GPU Direct for GPUs. You want to have the acceleration engines. You want to have the MPI offloads. You want the switch to run the MPI operations if you want to achieve your performance goals, if you want to do more with less. And looking on the reliability aspect, we're going to provide a 1,000x higher reliability with a superior single integrity. We have no issues to run 25 gigabit per second per lane. We don't need all the huge integrity mechanisms to protect the data like the competition does. Now, we do have all of those mechanisms when you go larger and larger distances. But the superior single integrity and the superior reliability make sure that your data is being protected. And beyond all of the advantages of Mellanox, I think another part is the flexibility that we provide for our users to use our network for x86, for power, for GPU, for ARM, for FPGA, basically for any compute element that exists out there. And our users can mix and match and use the same hardware and the same software to connect any of compute infrastructures and ability to mix and match and in the future decide what works best for them. So moving forward, the interconnect is the competitive advantage. We're seeing more and more intelligence being moved to the interconnect. We're seeing more and more users, government labs, universities, commercial users drive the need for increasing the intelligence of the interconnect, because the more you do on the data when it flies, the more things you can do faster and in real time, and that's become critical. So we provide the performance, we provide the scalability. It's proven, and it enables you to use the infrastructure of today to continue and scale it in the future, and together with our users to pave the road to Exascale. So that's the news for supercomputing, Rich. Switch IB2 is going to be a very exciting announcement, and we're definitely going to see many users beginning of next year deploying their system with Switch IB2.
Well, I guess, yeah, Gilad, thank you for that. My first question was, yes, does Switch IB2, does that become part of your full product suite then, going forward?
Yes, Switch IB2 will start having Switch IB2 end of this year, beginning of next year, and it will be on all the switch options that we have today, from top of rack switches up to the modular switches, and it will continue and bring more and more intelligence to the network and high performance for our users.
Well, great. So my next question had to do with programming, Gilad. I mean, when you move MPI operations out to the network, does the programmer have to go figure out how to make all that work and coordinate with these various processing elements, or how does that work?
No, of course not. So on the application side, the application continues to run as is. There is no need to change the application at all.
Mm-hmm.
The changes are happen from the MPI library and down to the network. And from Mellanox perspective, first, we are working with all of the MPI library companies to bring those modifications into the MPI so they can take advantage of it. Second, we also provide libraries from our own side, which are open source based, which enable people just to take them and incorporate with the MPI that they're using, and they gain support for MPI in the network. So from application perspective, no change needs to be done. It just go and put the intelligence in the network and enjoy a much greater performance.
Awesome. Well, so Gilad, I guess the last question is will you be showing this off at SC15, and when will it be available for purchase?
Yeah, we're definitely going to show Switch IB2 at Supercomputing 15. And we welcome everyone to come to the Mellanox booth and see the world's first intelligent switch. We're going to start shipping end of this year and through the beginning of next year, and expect to have multiple systems next year where they're going to use Switch IB2 and enjoy a dramatic increase in performance because of that.
Well, that's terrific. Well, Gilad, I want to thank you once again for telling us about this, and thanks for coming on the show today.
Thank you very much.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.